Hi everyone, we are going to go over the study guide for the 4.1 to 4.3 quiz that's tomorrow. Remote learners, please remember that you are expected to take your quiz during your scheduled geometry period, as well as to log into my Google Meet. If you have any questions about this, please email me ASAP. So let's start with number 1. We're going to use the figure below to solve for x, and then we're going to state what type of triangle we have. Let's remember that the interior angles of a triangle add up to 180 degrees. So we have 2x as one angle, x minus 10 as our second angle, and 55 as our third angle. So I'm going to add those up, set them equal to 180. So here we go. 2x plus x minus 10 plus 55 is equal to 180 degrees. Let's combine our like terms. So 2x plus 1x is 3x. Negative 10 plus 55 is a positive 45 is equal to 180 degrees. Subtract 45 from each side. 3x is equal to 135. Divide by 3. X is equal to 45. All right, so now if I plug this into my equation, so 55 is already 55 degrees, I can't plug x into there. I can plug x into this equation here, and 2 times 45 gives me 90. So I actually can stop right there. Since this angle here is 90 degrees, what type of triangle do I have? Well, I have a right triangle. And remember, to be a right triangle, you just need one angle that equals 90 degrees. All right, question 2. What is the value of x, y, and z? And then describe each triangle by its angles. All right, I'm going to scroll down a little bit here. So let's start by finding x. So I'm going to focus on this triangle here. And I know that the sum of the angles in a triangle equals 180 degrees. So that means that x plus 60 plus 31 is equal to 180. Combine your like terms. So x plus 91 is equal to 180 degrees, which means then that x is equal to 89. All right, so I'm going to write that up here. So x is equal to 89. Once I solve for x, I can now solve for angle y. So I know that these two angles are a linear pair. So since x is 89, I can solve for y because x plus y has to equal 180 degrees. So x we know is 89 degrees plus y is equal to 180. Subtract 89 from each side. We end up getting that y is equal to 91, and I'll write that up here, 91, and I'll also write it here, 91. Now the last angle we need to look for is angle z. So if I focus on this triangle here, I know that the sum of that triangle is 180, and so I have an angle measure of 25, 91, and z. So when I add those up, it's going to equal 180. So let's do that together. So 25 plus 91 plus z is equal to 180, which means z then is equal to 64. So let's label that 64. The next part I want to fill in is describe each triangle by its angles. So remember, a triangle can either be an acute triangle, an obtuse triangle, or a right triangle. So if I look at triangle ABC, That is the entire triangle. So this triangle right here. So to classify it by its angles, I need to kind of look at them and add them up. I see this one is 60, this one is 65. What is this angle? Well, when you add those up, you get 56. So this would be an acute triangle. All three angles are less than 90 degrees. Now let's look at triangle ABD. Now triangle ABD is our purple triangle. And once again, if I look at all the angles there, I have 60, 31, and 89. Those are all less than 90 degrees. So once again, we have an acute triangle. And lastly, I have triangle BDC. So those angles are, I have 25, 91, and 64. So this 91, since it's greater than 90, that means that that triangle is an obtuse triangle. Question number 3, use the figure below to solve for x. So I have an exterior angle here and two interior angles, so I'm going to use the exterior angle theorem, which just states that the exterior angle is equal to the sum of the two non-adjacent angles. So when I set this up, I'm going to have the exterior angle, which is 6x minus 10, is equal to the sum of the two non-adjacent, which are these angles right here. So 82 plus 2x. All right, so now we just need to solve for x. So I'm going to start by subtracting 2x, subtracting 2x. So those cancel, and I'm left with 4. Let's try that again. 4x minus 10 is equal to 82. Then I'm going to add 10, So 4x, that cancels, is equal to 92. Divide by 4 on each side. X then is equal to 23. So my answer is 23 is equal to x. Question number 4, in the diagram, angle B is congruent to angle E. I'm actually going to make that marking so I know as I go through this problem. So those two angles are congruent, meaning they are the same measure. Angle C is congruent to angle F. So this angle here is congruent to this angle here. Find the value of x. Now I'm going to apologize that our figure's a little blurry, but we do then know by looking at this figure that angle A and angle D are congruent. So if they're congruent, they are the same measure. So I'm going to set those two equal to each other. So angle A is really equal to x plus 50. And angle D is equal to 75. So if I subtract 50 from each side, this means that x is equal to 25. Question number 5, a triangle has the given vertices. Classify the triangle by its sides, then determine if the triangle is a right triangle. So for this problem here, I am going to need to find the distance formula because I'm classifying the triangle by its sides. Are the side lengths all congruent, which means they'd be equilateral? Are the side lengths all different, which means it would be scalene? Or are two of the sides congruent, meaning it would be isosceles? So let's remember that the distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. We're first going to find the side from point A to point B. So I'm going to call this x1, y1, x2, y2. All right, so let's plug those coordinates right into our distance formula. I end up getting 1 minus a negative 4 squared I'm sorry, let's try that again. X2 is 0, not 1, minus x1, which is the negative 4. And I'm going to square all that, plus, I'm going to do y2, which is 1, minus 4, and I'm going to square this. All right, so when I put this in my calculator, I end up getting the square root of 4 squared plus 3 squared, which if I simplify this, it's the square root of 9 plus 16, which is equal to the square root of 25, which simplifies to positive 5. Next, I'm going to find the distance from points B and C. So I'll call this one x1, y1, x2, y2. All right, so let's plug in what we know. So I have negative 2 minus 1 squared plus negative 4 minus 1 squared. We're going to simplify this. This will be the square root of negative 3 squared plus I am so sorry again. The x1 is 0. I don't know why I keep looking at this. So this should be 0. So it's negative 4 minus 0. All right, so the first part, the y's were correct. So negative 3 squared plus negative 4 minus 0 is negative 4 squared. So we're going to simplify this. It's going to be a positive 9 plus a positive 16, which is equal to the square root of 25, which is equal to 5. So right away we can see 2 of the sides are congruent. Let's see if the third side is as well. So let's find the side length of AC. So this is going to be x1, y1, x2, y2. Let's see if I can get this right on the first try. So negative 4 minus a negative 1. So negative 4 minus a negative 4. I'm going to square this. Plus negative 2 minus 4. So negative 2 minus 4. Square that. All right, so I'm going to simplify this. And negative 4 minus a negative 4 is 0. So 0 squared plus a negative 2 minus 4 is negative 6. I'm going to square this, which gives me the square root of 36, which is equal to 6. So what type of triangle is triangle ABC? It would be an isosceles. So an isosceles triangle, because 2 of the sides are congruent, this side and this side, and then we have one side that is not the same. All right, number 6, we want to find the measures of the angles A, B, and C. All right, so let's start with angle A. So once again, we have our triangle here. It adds up to 180. So that means that angle A is equal to 103 degrees. So I'll write that in here, 103. Let's then find the measure of angle B. Well, we know that angle B and angle A are a linear pair, which means they add up to 180. So that means that angle B has to equal 77. So B is equal to 77. And finally, to find angle C, I'm going to look at this triangle here. We know that the angles add up to 180. So therefore, angle C has to equal 46 degrees. Number 7, if triangle RPQ is congruent to triangle JKL, then we want to figure out all the different parts. Now, this is our congruent statement. Remember, you want to follow the order of letters. The order of letters are going to tell you what's congruent to what. So, for example, I'm going to look at these angles. So I'm going to start on this side. So angle P. I look here, angle P is the second letter in this triangle, which means it's also going to be congruent to the second letter of this triangle. So angle P is congruent to angle K. We're going to do the same thing for J. So angle J is the first letter here. So it has to be congruent to the first letter of this triangle, which is angle R. And finally, angle Q is the third or last letter here, which means it's congruent to the third or last letter of that triangle, which is angle L. So just like I said, the order matters for the angles, the order also matters for our side lengths. So if I look at side length, I'm going to start with the bottom JK. JK here are the first two letters of that triangle, which means the side length it's going to match with is the first two letters of this triangle, which is RP. PQ is the last two letters of this triangle, which means it's going to be congruent to the side lengths with the last two letters here, which is KL. And the reason I skipped the first one was because this is a little bit different. We have L and J, so we looked at the last letter and the first letter. So that means that the last letter here and the first letter here is going to be our congruent statement. So Q and R. And I'm done. So for question 8, it states, graph the triangle whose vertices have the coordinates given below, then draw a reflection over the x-axis. Since this is a Polaris quiz, we can't actually graph this, but I will know the new coordinates of my shape, knowing that it has a reflection over the x-axis. So let's just remember that if you have a coordinate x and y, and we reflect it over the x-axis, the x value is going to stay the same, which is a positive x, but your y value is going to become negative, so it's going to become negative y. So the only coordinate I change is the y coordinate. So let's start with the new coordinate for m. I'm going to keep x the same, which is negative 7, and I'm going to negate the y value, which would be negative 3 then. So for my new n coordinate, keeping x the same, which is negative 1, and negating the y, which once again would be negative 3. And then for coordinate p, our new coordinate, the x would stay the same, and I'm going to negate the y value. And I'm done. All right. For number 9, I want to describe the given translation using coordinate notation. So every point moves to the right 3 and up 4. So this would be a translation. So if you're moving to the right 3, that's moving the x value over to the right. And to the right would be a positive on a coordinate plane. So it's x plus 3. And if you move up, that's moving the y coordinate. And if you're moving up, that's positive. So y plus 4. B, every point moves down 3 units and to the right 5 units. So we're going to start with the x because x is left and right. So if you're moving right 5, that is a positive 5. So x plus 5. And then down 3 units, that's the y, moving it down, so that's negative. So y minus 3. Every point moves to the left 8 units. So this left and right is the x. So left would be negative because we know right is positive. So this is x minus 8, but it doesn't say anything about the y. It doesn't tell me if it's going up or down, which means the y is going to stay the same. So I'm just going to keep it as y. And then finally, every point moves to the left 6 and up 2 units. So left 6 and up 2 units. This would be x minus 6, y plus 2. Number 10, what is the translation image of this coordinate negative 5, 7 after the translation of xy transforms to x minus 2, y plus 4? All right, so my original x value is 5. I see here I'm going to subtract 2 from here, so I'm going to write minus 2, comma. I have my y value, which is negative 7. I see that here. And with my y, I'm going to add 4. So when I do the math here, I end up getting negative 7, negative 3. 11, identify the coordinates of the image point formed after negative 1, 3 is reflected over the x-axis. So once again, remember flipping over the x-axis. If you have your original coordinate x, y, this would keep the x the same, but the y would change to negative y. All right, so if I have the coordinate negative 1, 3, x would stay the same, negative 1, and my 3 would negate to negative 3. Reflect the polygon over the y-axis, then translate it using the image. We're going to x plus 1 and then y plus 9. All right, so flipping it over the the y-axis means that we're going to keep the y value the same, but make the x value negative. So for example, I'm going to write that out. So xy, this would be in this time, the x is going to be negative and the y is going to be the same. So if I look at these points, it's going to be hard for me to do it one by one, but I'm going to pause the video and draw it over so you can kind of see what happens there. All right, so you should see that I took my original black figure, flipped it over the y-axis to form my new figure. So now I'm going to use this translation, which is move my figure over 1 to the right and up 9. So in the next part, you're going to see me actually do that. So now you can see with the blue image that I moved my purple figure up 9 and to the right 1. All right, next. Are the following congruence transformations? If yes, describe which type and explain, and then if no, explain why not. So looking at triangle ABC, which is this triangle here, ABC, and triangle DEF, are these two triangles congruent? Or is there a transformation that occurred? So the answer here is no, because those two triangles are not congruent. They are not the same shape. Now look at triangle ABC and GHJ. So are those two triangles congruent? They are. They're the same shape. Now we need to figure out what happened here. So this would be yes, they are congruent. And how shape ABC got to shape GHJ would be by a few reflections. So it'd be a reflection over the x-axis and then a reflection over the y-axis. And then lastly, ABC to KLM. KLM is here. Are these congruent? Yes. And how could you transform this? It would be from a translation, just a slide. For question number 14, what is the value of x? So to find this, we got to kind of put all of the pieces together. So x is this angle right here in the middle. So I first need to figure out what would this angle right here be, and I'll call this y. Well, 130 and y would be a linear pair, which means that they add up to 180. So if one of the angles is 130, it means y would have to be 50 degrees. All right, so let's keep going. So since this angle now is 50, I see that this angle is 90 degrees. Then I need to figure out what is this angle right here. Well, that angle would have to be 40 because we know that the angles inside a triangle add up to 180 degrees. So now we're almost done. So since this angle is 40 and we have x here, we need to figure out, wait, what is this angle over here? And I'll call this angle Z. All right. Well, looking at this triangle, I see that there's a 90-degree angle, which means this is equal to 90 degrees. So once again, the interior angles add up to 180. So we can solve for Z, which means Z is going to equal 39. So now I only have one more step to find angle X. If I look at my diagram, I see that 40 plus X plus 39 is equal to 180 because those three angles create a line. So I can now solve for X. When I combine these and move them over, I end up getting that X is equal to 101. All right, so let's try this again. Very similar. So I want to figure out what is the measure of this angle here. Okay, so first off, I see that this is 110 degrees. This is a vertical angle to the angle here, which means this is also 110 degrees. So now I got to figure out this angle here, and I'll call this X. Well, these are a linear pair. So 33 plus 110 plus X, and I'll write that down. 33 plus 110 plus X is equal to 180, which means that X is equal to 37. All right, so now I need to look at my triangle here, and I need to find the other angle right here from my triangle. Once again, the interior is equal to 180, so that last angle must then equal 53 degrees. So now looking at that angle with this angle, this is just a big puzzle. I know that 53 plus angle A has to equal 180 because once again, they are a linear pair. So that means A has to equal 127. 16, suppose a triangle ABC is congruent to triangle DEF if AB is equal to 27 feet and measure of angle B is equal to 75 and the measure of angle F is equal to 74. Is it true or false that the measure of angle E is equal to 31? Well, let's kind of draw this out. All right, so as you can see, I drew this out. So this is D, E, and F. And so this would mean no. E would not be, this is false, E would not be 31, it would actually be 75. Which pair of lengths can be two sides of an isosceles triangle which has a perimeter of 52 inches? Would it be 15 and 25, 15 and 22, 12 and 22, 16 and 21. Remember, isosceles means two angles or two sides are the same. So the only option we have that would work here would be B. And this is why that would work. So if 15 is doubled, that would be 30. So 15 plus 15 is 30 plus 22. That will give you a perimeter of 52 inches. 18, if triangle ABC is congruent to triangle DEF, AB is equal to 10, measure of angle B is equal to 27, and the measure of angle F is equal to 14. Which of the following statements is false? I'm going to draw this picture out because I have to see it to be able to tell what is true and what is false. So don't mind my very sloppy sketch, but if we look at all of our answer choices, the one that is incorrect is C here. It's telling us the angle E should equal 139 degrees, which we see that it actually equals 27 degrees. And I should state that 16, 17, and 18, these are really challenging problems. You won't see any this hard on the assessment tomorrow, but you will, you just should know these in general, but these are very, very challenging. So if you didn't understand these, don't stress out about them, but it's just kind of good to know them. All right, almost done. So 19, if triangle MNO is congruent to triangle VXW, which statement is not true? And it's not true that A, that segment NO is congruent to segment VW. And once again, you could sketch this out and see. And finally, which graph represents a reflection in the x-axis? And that would be B here.